From the previous video, we have learned how to differentiate functions using its definition. However, differentiating functions using such method is very time consuming and can sometimes be not as straightforward, especially when it involves fractions and square roots or anything alike. So in this video, we will learn how to differentiate functions without undergoing such process and learn about the various differentiation rules for algebraic functions. So to start, let us first present the various differentiation rules for algebraic functions. I have already written it, so the first one is the derivative of a constant. So in this case, all of these are differentiated with respect to x. So if any constant is differentiated with respect to any variable, but in this case we have just chosen x, is always equal to 0. So if we differentiate any constant, the result would be equal to 0. The next one is what we call the power rule. In this case, if x is raised to an exponent n, we can get the product of n times x, and the exponent will now be subtracted with 1. The next one is the addition rule. So in this case, if we have two functions where u and v are both functions of x, and if we differentiate it with respect to x, the result would be the addition of the derivatives of these two functions. The derivative of u with respect to x and the derivative of v with respect to x. The next one is the product rule. If we differentiate the product of two functions where u and v is still functions of x, the result would be the first function times the derivative of the second function. I forgot dx here, so we have dx here. So the derivative of the second function with respect to x plus the second function times the derivative of the first function. The next one is what we call the quotient rule. So if we have a quotient of u divided by v, the result would be v times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. So to understand this, let's have an example. So let's say we have our first example. Let's say y is equal to the square root of 5. So if we want to differentiate this, we will just have to put the derivative operator here. So the derivative of y with respect to x. And this would be the same to the other side of the equation. So we just need to put the operator here. So in this case, this will become the derivative of y with respect to x is equal to what square root of 5? Remember that square root of 5 is a constant. So any constant, its derivative is equal to 0. So therefore, our answer is 0. So there's no need to undergo this process. We just need to memorize these few rules. So let's have another example. Let's say y is equal to 7x cubed. Let's fix that cube. So to start, again, we just need to put the operator here so that we can know what variable are we differentiating with respect to. So in this case, we are respecting this function with respect to x. So the derivative with respect to x. This now becomes the derivative of y with respect to x. And this is no longer a constant. But we can use this second rule, which is the power rule. So the power rule states that the exponent will be brought down here. So the exponent here is 3. So we multiply 3 to this term. So 3 times the same, 7x raised to 3 minus 1. So if we simplify this, this would become 21. X and 3 minus 2 is 2. So this is now our derivative. So let's have another example. So let's say y is equal to x cubed plus 7x raised to negative 6 minus 2x raised to the fifth power plus pi over 3. So if we want to differentiate this, the first step that we're going to do again is just put the operator here. So let's just make some space here. And let's differentiate this with respect to x. So the same with this side. The same with this side. So let's include all of these terms. So this would result to the derivative of y with respect to x. So if you could recall, we have another rule here, which means that the derivative of any sum would be the derivative of those individual terms. So in this case, we can now simplify this with the derivative of x cubed plus the derivative of the second term, which is 7x raised to negative 6. The next one is the derivative of 2x raised to the fifth power. So we lack some space here. So let's move this down here. So what's left is this pi over 3. So plus the derivative with respect to x of pi over 3. Now, this simplifies our solution. This now, we can now differentiate this with the power rule. We bring down 3, we copy x, and we subtract 1 from the exponent. This would become 2. Okay, the next term plus the negative 6, we will multiply negative 6 here. We bring down this times 7x raised to negative 6 minus 1. So negative 6 minus 1, this is now equal to negative 7. The next one, we forgot a close parenthesis here. So let's just move this. Let's just move this a little bit here and minus the derivative of this. We bring down 5 times 2x raised to 5 minus 1 is 4 plus pi over 3. Pi has a value. Pi is 3.14. So if we differentiate this, since this has a value, this is now a constant. And constant divided by constant is still constant. So this would become, yes, it's 0. So further simplifying this, this would become 3x squared. So positive times negative, this would become negative. And 6 times 7 is 42. X and copy the exponent negative 7. And this would simplify to negative 5 times 2 is 10. X raised to the fourth power. And this is now our derivative of the function. So this is now the derivative of y with respect to x. So let's have another example. Let's now change the variable. Instead of y, let's say w is equal to 1 over t squared minus 1 over t raised to the fifth power. So in this case, we want to differentiate this with respect to t. So let's just copy this and add a little bit of space here for the derivative. So we want to differentiate this with respect to t. So the derivative with respect to t. So in this case, the first step that we can do is we can first apply the sum rule. So this would now become the derivative of w with respect to t is equal to the derivative of this first term, 1 over t squared, minus the derivative of this second term, 1 over t raised to the fifth power. So if you can see, we can now apply the quotient rule. So let's review the quotient rule. So the quotient rule is a little bit lengthy. Instead of using this quotient rule, we can still use the power rule. But if you can recall in the laws of exponents, we can now represent this as t raised to negative 2. When we have a negative exponent, we get its reciprocal. So the same with this now becomes t raised to the negative fifth power. So instead of using this, let's now replace this with t raised to negative 2. And this becomes t raised to negative 5. So in this case, this now becomes, we bring down negative 2 here. T, negative 2 minus 1, this now becomes negative 3. And this now becomes, we bring down negative 5. T, negative 5 minus 1 is negative 6. And this simplifies to negative 2. T raised to negative 3. Negative times negative, this becomes positive 5t raised to negative 6. And this is now our derivative.